Hello and welcome to this video where I will be going through the Chapter 2 study guide. Our first question has us finding the derivative of this function with the limit process. And so this requires us to use the correct method. If you just found the derivative using, for example, power rule and chain rule, you would get the correct answer, but you would not get full credit because you didn't do it with the limit process. So as you recall, the limit process uses the limit definition of the derivative, which we should start by writing. So that is just the derivative of f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So as you can see, when h equals 0, this is going to give us a 0 over 0. And so this requires us to use some methods from the previous chapter to evaluate this limit. So first, let's start by plugging in this value, x plus h, into our function f of x. And so that's going to give us this. Remember that we have to keep writing the limit symbol with the proper notation. And then f of x plus h, we simply replace x with x plus h in the original function. So that gives us 5 times x plus h plus 7. I'm going to square root over that. And f of x is here, 5x plus 7. And then all of this is over h. Right? Next, I'm going to expand that 5 times x plus h. Um, Actually, we'll keep it unexpanded. You could have done that if you wanted, but I'm just going to leave it like that. And then to evaluate this limit, what we have to do is rationalize the numerator. And this was a technique that you guys might remember from the previous chapter. So by rationalizing the numerator, what I mean is that we should multiply both the numerator and the denominator by the conjugate of the numerator. Very similar to rationalizing denominators, except this time we're interested in rationalizing the numerator. So what does that look like? We're going to multiply both top and bottom by this fraction here. And this fraction is simply equal to 1, so it doesn't actually change the value of our expression, but it will help us to evaluate this limit. We're going to multiply by this fraction. And that means that the top is going to become a difference of squares. You can see that I have a difference multiplied. Sorry, I've multiplied by the wrong fraction. I meant to write a plus here. Okay, that's supposed to be a plus. And so you can see that as I multiply out the whole numerator, this is going to yield a difference of squares. And so I'm going to have 5 times x plus h plus 7 minus 5x plus 7. And you could confirm that this is the case by expanding by hand using FOIL. And then the numerator and then the denominator is simply going to be h times what we multiplied on the right side. All right, so make sure you see how this is the case. And then the final steps are just going to be simplifying this expression. And so now we can expand the numerator. So distribute that 5 across the x plus h. And so that is going to give us 5x plus 5h plus 7 minus 5x minus 7. Notice how the minus sign distributed to the plus sign of the 7. And then the denominator I'm going to keep the same. That doesn't really simplify. But now, as you can see, we've successfully rationalized the numerator. There are no more radicals in that expression there. Okay, as you can see in the numerator, the 5x and the 7 both cancel out. And so what I'm left with is just a 5h. I'm left with a 5h in the numerator. Right? And so the h in the top and the h on the bottom are going to cancel out. And so I'm simply left with 5 over square root of 5x plus h plus 7 plus square root of 5x plus 7. So now, as you can see, if I plugged in h equals 0, I'm no longer going to get a divide by 0 error. Because the bottom evaluates out to something that's other than 0. And so as my final step, I can now plug in the h equals 0, which means I can drop the limit symbol now. And when I plug in h equals 0, this 5 times x plus h plus 7 becomes the same as the 5x plus 7. And so what I'm left with is simply 5 over 2 times the square root of 5x plus 7. And that would be my final answer. You could have also rationalized this, um, and you would have gotten this expression here. But both are fine. Okay, so just to summarize, we started with the definition of the limit with the derivative, and then we plugged in x plus h and x into the original function. And then for this particular limit, we had to rationalize the numerator using the conjugate in order to correctly identify the final answer for the limit. If there wasn't a square root, but instead it was another expression, then you would have had to use a different method for evaluating the limit. Let's go on to the next question. This is a kind of unique question that we didn't necessarily go over in class, but it's actually quite straightforward. So the question gives us the graph of the function, and we're asked to find the graph of the derivative of that function, right? We were asked to find the graph of f prime, and that's just the derivative of f. So um, the easiest way to solve this question is probably by simply guessing what the function f is equal to. And so when we look at this graph, what we see is an upside down parabola that opens downward. And so that tells us that f of x is probably going to be something like negative x squared. Maybe not exactly like that. It turns out it is exactly negative x squared, but we know there has to be a negative quadratic expression. And so now we can very easily find the derivative using power rule. And so the derivative is simply negative 2x. And all we need to do now is look at these functions and think about which one most resembles negative 2x. And the answer is A, because we have a linear function with a downward slope. So it's negative 2x. Um, Alternatively, you could have analyzed this using the graph itself. We do know that the derivative when x is negative should be positive, right? Because all these slopes are all positive. So when x is negative, the derivative of f of x must be a positive number. And then we also know that when x is equal to 0, the tangent line has a horizontal slope. And so we know that the derivative must be 0 when x equals 0. And finally, when x is positive, we know that the tangent lines are all negative sloping. And so that means the derivative must be negative. And if you had compared all of the graphs with those facts, you would have found that only graph A satisfies those three criteria. Next, going on to question 3, we have to find an equation of the tangent line to the graph of the function at a specific point. And so this calls for a derivative because first we need to find the slope, right? We're given the point that the line must go through. That tangent line must go through this point, but we don't know what slope it is. And so that's exactly what derivatives are for. They tell us the slope of a tangent line. And so we're going to calculate the derivative of this function at that particular point. And so the derivative of f is something that we can calculate using power rule, since it's the product of different powers of x. And so the derivative is simply 2x plus 7. And now we're trying to evaluate the derivative at this point. So that means we're going to evaluate f prime of x at the point x equals -5, right? This is the x value, and this is the y value. And so we find that f prime of -5 is equal to 2 times -5 plus 7, which is -3. And so that tells us that we're looking for a line with slope -3 that passes through the point -5, -8. And so this is simply a matter of using point slope form, right? Remember our formula, y minus y1 equals m, the slope, times x minus x1, where x1 and y1 are the coordinates of the point that the line passes through. And so we're simply going to plug in our values of m and x1 and y1. And we're left with y minus y1, which is -8, equals m, which is -3, times x minus x1, which is -5. And so this gives us y plus 8 equals -3 times x plus 5. And if we continue to evaluate this, we would be left with y equals -3x minus 15 minus 8, or y equals -3x minus 23. Question 4 has us finding the slope of the graph of the function at the given value. All right, so this calls for a derivative because that's what it means to have a slope of a particular graph. So first, I'm going to rewrite the function in a more convenient term by writing it in terms of powers, because I don't want fractions, because I want to avoid using quotient rule if possible. So I can rewrite the function f of x as -4x squared plus 3 times x to the power of -2. So that'll greatly simplify my derivative. And then I can calculate the derivative using power rule, and that'll give me -8x plus 3 times -2 x to the power of -3, right? The -2 comes to the front, and I reduce the power by 1. The -2 becomes -3. In other words, that's -8x minus 6 times x to the -3. Now I simply need to plug in my given value of x, which is 3. And so f prime of 3 is equal to -8 times 3 minus 6 times 3 to the power of -3. And if I calculated this, this would give me -24 minus 6 over 27. And 6 over 27, I can simplify that. That's just 2 over 9. And so I'm left with negative 216 minus 2 all over 9, which is -218 over 9. which is choice D. Yeah, should be right. Do the next one. Determine all values of x at which the graph of the function has a horizontal tangent. So when I read this question, it's just telling me find all values of x such that the slope of the graph of the function is zero, because that's what it means to have a horizontal tangent. A horizontal line has slope of zero. And so that's essentially asking me where the values of x are such that the derivative is equal to zero, because the derivative is a slope. And so I can calculate the derivative using power rule. And that's going to give me 4 times x to the third minus 108. And the 6, that the derivative of that is 0. Okay? And so I'm simply looking for the values of x such that this derivative is equal to 0. So that means 4x cubed is equal to 108, or x cubed equals 27. And so that means x equals 3. That's the only value of x such that the derivative is equal to 0. Question 6. A ball is thrown straight down from the top of a 280-foot building with an initial velocity of negative 14 feet per second. The position function is s of t equals negative 16t squared plus v naught t plus s naught. What is the instantaneous velocity of the ball after 1 second? So this looks like a complicated question, but we should first use the fact that a position function, the derivative is simply going to be the velocity. That's the definition of velocity. The velocity is the derivative of position with respect to time. And so that tells us that v of t, if we allow that to denote the velocity, v of t is going to be equal to ds dt, which we can calculate as negative 32t plus v naught. That's just by power rule. The derivative of negative 16t squared is negative 32t, and the derivative of v naught t is v naught. And then s naught is a constant, and so that's just going to be 0. All right. And then a second fact that we're told is that the initial velocity is negative 14 feet per second. So that tells us that when t equals 0, the velocity here must be equal to negative 14. And so that means that v0, which is equal to negative 32 times 0 plus v naught, is equal to negative 14. Well, that simply tells us that v naught, the constant initial velocity, is negative 14. Now the question is finally asking what is the velocity of the ball after 1 second? And so that's essentially asking us to evaluate v of 1. What is the value of the function v of t when t equals 1? And so that's going to be equal to negative 32 times now t equals 1 plus v naught, which we just found, right? Which is negative 14 minus 14. And so my final answer is going to be negative 32 minus 14, which is negative 46 feet per second. The answer is C. So in this question, the first fact that the building is 280 feet tall is actually not needed. All right, question 7 is a differentiation question. And this is going to require us to use product rule because we have the product of two different functions of s that we do know the derivatives for. And so by using product rule, we're going to find that the derivative of g with respect to s, make sure your s's are different than your 5s in your handwriting here. We're going to differentiate the first factor and leave the second factor alone. That's going to be negative 5 times s to the power of negative 6. And the second factor we're going to leave alone. So that's cosine of s. And now we are going to add the first factor left alone with the second factor differentiated. And so the derivative of cosine s is negative sine s. And so my final answer is negative 5 s to the negative 6 cosine of s minus s to the negative 5 sine of s. And so that looks like um, choice B. Yeah, choice B. Next question, very similar. This is also product rule. And so the derivative is going to be 4s cubed times tangent s, because we leave that alone in product rule. And then we're going to add s to the fourth times the derivative of tangent s, which is secant squared of s. And so that looks like it corresponds to choice B again, if I'm not mistaken. Yeah. All right. Question 9, differentiate this function. This is clearly a case in which we ought to use quotient rule because we have the quotient of two functions of x, to which we know the derivatives. And so using quotient rule, remember low d high minus high d low, all over low squared. So that tells us that f prime of x is equal to low d high, low times the derivative of the top, which is just 0 plus 1, right? So that's going to be multiplied by 1 minus high times the derivative of the bottom, which is 2x. 2x plus 0, all over low squared. So to simplify this, we're going to have to expand the numerator. We'll be left with x squared plus x minus, let's expand this in a big parentheses first to not get confused with the minus signs, minus 10x plus 2x squared. Again, all over x squared plus 6 squared, which we're not going to expand. That's not going to simplify very much. Now we're going to distribute the minus sign across the parentheses here. And then the x squared and the minus 2x squared will leave me with negative x squared minus 10x plus 6 all over x squared plus 6 squared. That's my final answer. That looks like it corresponds to choice E. Yeah. Next one. This has us finding a second derivative. That simply means we take the derivative twice. So after we found the derivative of f, then we find the derivative of the derivative of f. First step, we're going to use power rule. Find the first derivative of f. That's going to be 4 times 5/3 times x to the power of 5/3 minus 1, which is 2/3. And then we take another derivative, so f prime of x is equal to 4 times 5/3. Constants stay the same. Then we multiply again by 2/3. So power rule once more. And finally, x is to the power of 2/3 minus 1, which is negative 1/3. So the final answer is 40 over 9 after we multiply those fractions, x to the power of negative 1/3. And that's D. Next, find the derivative of this function here. Here we're going to have to use chain rule, right? The reason is that we have a function on the outside, that power of 5/3, and we also have an inside function, the 1 plus 4t. And so to do chain rule, we're going to take a derivative of the outside function with the inside left the same. And so the 5/3 will come to the front, which is just power rule. Inside stays the same, so 1 plus 4t. And that's going to be to the power of 5/3 minus 1, which is 2/3. We're not done yet. We have to now multiply by the derivative of the inside function. That's chain rule. And so the derivative of the inside is 0 plus 4. So it's 4. If I simplify this a little, bring the 4 to the front, I'm left with 20 over 3 times 1 plus 4t to the power of 2/3. Um, choice E. Next one is very similar. We use chain rule once more. So the outside function is that power of 4, and the inside function is the t cubed plus 4. So f prime of t, chain rule, doing the outside function first. So 4 times t cubed plus 4 to the power of 3 times 3t squared. That's the derivative of the inside. And so if I simplify that, I'm left with 12t squared times t cubed plus 4 cubed. Next question. Here I have to use multiple rules. I first am going to use product rule because I have a product of two functions, x cubed and 7 plus 8x to the fourth. But then after that, I'm going to also have to use chain rule when I'm finding the derivative of 7 plus 8x to the fourth, because that's a composition of two functions, right? We have a power 4 on the outside and the 7 plus 8x on the inside. All right. So product rule first. I'm going to find the derivative of the first factor, leave the second factor alone. That's 3x squared times 7 plus 8x to the fourth. And now I'm going to leave the first factor alone. X cubed stays the same. And now I have to find the derivative of the second factor, sorry. And that's going to first require finding the derivative of the power of 4 while leaving the inside the same. So that power of 4 is going to come to the outside. And then I'm going to have 7 plus 8x to the power of 3. And then finally, I'm going to multiply by the derivative of the inside, which is 0 plus 8. So that's multiplied by 8 here. And if I simplify this, I'm going to be left with this. 4 times 8 is 32. All right, so if you left this as your final answer, that would probably be fine. But in case there's multiple choice, you might have to actually simplify further, in which case you would have to factor out a greatest common factor from these two terms. And clearly the greatest common factor is x squared times 7 plus 8x to the third. All right, because this term contains an x squared and a power 4, whereas this term has a power of 3 and a power of 3. So the greatest common factor is x squared times 7 plus 8x to the third. And then I just collect what I'm left with. That's 3 times 7 plus 8x plus 32x. And so that would simplify to x squared times 7 plus 8x to the third times 24 plus 32 is 56x plus 21. 24 plus 32, 56. And then you might also need to factor out a factor of 7 from this term, which might leave you with 7 times x squared, 7 plus 8x to the third, and then times 3 plus 8x. That would be a most simplified answer, but if it was a multiple choice, you could also leave this as your final answer as well. Next question. Let's see how many more are left. It's quite long. 24 questions. Wow. Okay. Find the derivative of the function y equals -2 cosine 6x. So this is going to require chain rule because we have a cosine on the outside and a 6x on the inside. So dy dx is equal to, so I'm first going to find a derivative of the outside. And so the derivative of cosine is negative sign. So this -2 will become a positive. So 2 times sine of 6x, right? Leave the inside the same for chain rule. And then finally multiply by the derivative of the inside, which is 6. The answer is 12 times sine of 6x. Just choice A. 15, evaluate the derivative at this given point. And so I'm basically just interested in the value of this function when t equals 5, right? T is the x-coordinate, the independent variable. And so what is the derivative of f of t? Well, you could use quotient rule, but I'm going to do it an easier way by converting this to a power. A reciprocal of t minus 1 is just t minus 1 to the -1 power. And so this just calls for chain rule when I find the derivative. That means f prime of t is equal to 9, and the power comes to the front, so 9 times -1 times t minus 1 to the -2, and then I have to multiply by the derivative of the inside function, which is t minus 1. But that derivative is just 1, and so it doesn't change anything. And so f of t is equal to -9 over t minus 1 squared. The power of -2 is just the reciprocal of a square. And so now to find the derivative at that point, I'm going to plug in t equals 5. That's going to give me f prime of 5 equals -9 over 5 minus 1 squared, which is 16. That's my answer. Choice A. Question 16. So this calls for implicit differentiation because I'm looking for the derivative of y, but I'm given an equation that doesn't have y isolated. So what I'm going to do is my usual steps for implicit differentiation. I'm going to take this equation and differentiate both sides with respect to x. Okay? And when I take the derivative, I need to remember that y is not a variable here. Well, it is a variable, but in particular, it's a function of x. And so whenever I encounter a derivative of y, I need to remember to use chain rule. Okay, so the derivative of x squared, that's just 2x. And the derivative of y squared, that's chain rule. First, I do the outside function, which is the squared. That gives me 2y. And then I need to multiply by the derivative of the inside, which is dy dx. Okay, that's the most important step for implicit differentiation. So make sure you understand why that is. Then the derivative of the right side is just 0 because it's a constant. And so now my goal is to find dy dx. So I have to isolate that somehow algebraically. That's 2y times dy dx equals negative 2x. And so now I just divide both sides by 2y. I'm left with dy dx equals negative x over y. Next question is very similar. Implicit differentiation, but now I have to evaluate the derivative at a specific point where I'm given the values both of x and of y. X is 7 and y is negative 1. So I'm going to take my equation and differentiate both sides with respect to x. And so on the left side, I'm going to use product rule. And so I'm going to first find the derivative of 6x and leave y squared alone. So that's just going to be 6y squared. Then I add, this time I leave the 6x alone and find the derivative of y squared. That's going to be 6x times 2y times dy dx. Right? Because the derivative of y squared, same as above, is 2y times dy dx. Finally, the right side is equal to 0. All right. And now my final step is isolating dy dx, because that's what I'm looking for. So let me bring the 6y squared to the other side. And so this is going to be 12xy dy dx is equal to negative 6y squared. Divide both sides by 12xy, and I have negative 6y squared over 12xy, which is also equal to negative y over 2x. If you cancel out the terms that are shared by the numerator and the denominator. All right, so my final step is just going to be plugging in the values that I'm given. So I'm told that x equals 7 and y equals negative 1. That means dy dx equals negative of negative 1, which is positive 1, over 2 times 7, which is 14. So that's my answer. Okay. Next question, more implicit differentiation. So once again, I'm going to take the derivative of both sides. So the derivative of sine x is cosine x. And then for the derivative of 5 cosine 11y, I'm going to have to use chain rule multiple times here. So the derivative of cosine, that's the first outside function, that's going to be negative sine. So I'm going to write negative 5 sine 11y. Right? I left the inside the same. That's chain rule. And now I need to multiply by the derivative of the inside. So I need to multiply by the derivative of 11y. But that's just going to be 11 times dy dx, right? Because the derivative of y is dy dx. Remember, I'm taking the derivative with respect to x, not y. So it's dy dx, not 1. And then the right side is just 0. And so if I simplify this a little, I can bring the cosine x to the left, to the right side. I'm left with, right, I can multiply the 5 and 11 here. That's negative 55 sine 11y dy dx equals negative cosine x, bringing it to the right side. And now I just need to isolate dy dx. So that leaves me with cosine x over 55 sine 11y. My answer. I think that's part A. Choice A. Question 19, more implicit differentiation. Same exact steps. So the derivative of x to the 8 is 8x to the 7th. The derivative of 8x is 8. Derivative of 13xy, that's a little tricky. We're going to have to use product rule here. It's going to come out to 13. Okay, derivative of x is 1, so 13y plus 13x times the derivative of y, dy dx. And finally, for y to the 8, we need to use chain rule. It's going to come out to minus 8 to the power, minus 8 times y to the power of 7 times dy dx. The right side is 0. Okay, so we're going to try to isolate dy dx. So let's move all the terms that don't contain that to the right side, and then factor the ones that do contain it. It's going to give me this. Okay, factoring out dy dx, then moving those other ones to the right side. And we're going to keep them all positive, so just have a negative in front of the parentheses. That seems to match the answer choices more. And then divide both sides by 13x minus 8 to the y7th. 8 times y to the 7th. Let's see if that matches anything. Um, doesn't quite look like it matches D or E, so I'm probably going to have to do another step where I make the denominator negative. So I multiply the denominator by this negative here. So that's going to give me 8x to the 7th plus 8 plus 13y over 8y to the 7th minus 13x. I think that matches choice E. And so I'm done. Let's do the next one. Okay, this is quite a interesting question. Maybe one that we haven't actually really seen before. This one has us finding the second derivative of y given a function including x and y. So this is going to have us, so the way to calculate this is by first calculating dy dx using implicit differentiation, and then taking the derivative once more to find the second derivative. Okay, that's the general outline of the solution. So we're going to first apply our normal process to find the first derivative of y, given this equation using implicit differentiation. So that's going to come out to 6x plus 14y dy dx, and the right side is 0. Okay? And then we're going to try and isolate dy dx. And once we've isolated dy dx, we can do another derivative to find the second derivative. So solving, this is going to give us negative 6x over 14y, which is also equal to negative 3x over 7y. And now we can do another derivative of both sides, which will give us the second derivative. Okay, so I'm going to do a derivative of left and right sides. This is going to require that I use quotient rule. Okay, so I'm going to do low d high minus high d low. The negative comes to the outside, and then low d high, so that's times 3, minus high d low, which is 7 times dy dx, all over low squared, 49y squared. Okay. Now I'm going to simply simplify the top, and I'm also going to plug in the dy dx that I found earlier into this dy dx here. I'm going to distribute the minus sign because that's outside the fraction right now. I'm going to distribute that to both terms in the numerator. It's going to give me negative 21y plus 21x dy dx. That's all over 49y squared. And I believe that's correct. And then plug in my value for dy dx from above, negative 3x over 7y. And so after simplifying, that is negative 21y minus 9x squared over 7 all over 49y squared. I'm sorry, it's not 9x squared over 7. It's just simply, um, it's 9x squared over y. 9x squared over y. Yes. All right. And then if you simplify that a little more by multiplying both the numerator and the denominator by y, you would be left with negative 21y squared minus 9x squared over 49y cubed is your final answer. Well, that's quite a difficult question that we haven't really encountered before. Okay. Question 21 is more implicit differentiation. We essentially have to find dy dx given an equation containing both x and y, right? Because the equation for a tangent line, that simply means that we're supposed to first find the slope because we're given a point. So if we find the slope of that tangent line, we'll be able to use point slope form. So we have to essentially find dy dx at 1, 5. That's what we're going to do. We're going to do implicit differentiation, do a derivative of both sides. And so the left side is going to become x plus y over 25 dy dx. Skipping a few steps here, but you can easily see that for yourself. Equals the right side is 0. And then I'm going to isolate dy dx by moving x to the other side. That's going to give me dy dx equals negative 25x over y, which you can confirm for yourself. And then the final step is to find dy dx at this particular point. So I'm going to plug in those values of x and y. And so dy dx equals negative 25 times 1, which is just negative 25, over y, which is 5. So the slope of the line at that point is negative 5. And so my final step is just to use point slope form. Y minus 5 equals slope 5 by negative 5. Slope negative 5. Well, actually, you can just look at the choices and see this question must be part D. Negative 5 times x minus 1. If you simplify that, you would get negative 5x plus 10. All right, question 22, we're on to related rates. Radius is increasing at a rate of 7 inches per minute. Find the rate of change of the volume. All right, so let's show the full work. Remember, set up, and then write a primary equation, then differentiate, and write the answer with units. So let's do the setup first. We're told that the radius is increasing at a rate of 7 inches per minute. So that's telling us a derivative, right? Because it's a rate. And it's increasing, so it's positive. So we're basically given that dr dt is equal to 7 inches per minute. Positive 7, right? And we're also told that r equals 11 inches. Finally, what we're interested in is the rate of change of the volume. So it's dv dt. Next, we're going to write the equation that relates V and R, and that's simply the volume of the sphere, 4/3 pi r cubed, which you're given. And so now the next step, right? Step 1, step 2, step 3. The third step is to differentiate both sides with respect to time. That's dv dt equals, okay, the cube is going to cancel out with the 3 here, so I'm left with 4 pi r squared. And don't forget to multiply by dr dt. It's changeable, right? R is also a function of t. And so now we just plug in the values that we already know. So we know that R is equal to 11 and dr dt is equal to 7. And so we are left with I don't know that in my head, but I'm guessing it's choice A, so 3388 pi. And then the units are inches cubed, because that's volume, right? And then our unit of time is minutes. Okay. Make sure you have the correct units. Always think about what is changing, and then what is the units of time. So the thing that's changing is volume, so that must be some kind of inches cubed. In the question, we're given inches, right? So it must be inches cubed then per minute. Did I do this correctly? Yeah, 3388. Okay, next question. Second to last one, right? All edges of a cube are expanding at a rate of 5 centimeters per second. So maybe let's draw a diagram. Right, we have a cube. And let's say that the side length of the cube is x. Okay. So we're basically being told that the edges are expanding at a rate of 5 centimeters per second. That tells us that dx dt is equal to 5 centimeters per second. We're also told that each edge is 30 centimeters. And we're asked to find how fast is the volume changing? In other words, what is dv dt? Okay, so that's the information we're given. And the second thing is we need to write the equation that relates v and x. That's just the volume of the cube. V equals the side length cubed. And the third step is to differentiate, so dv dt. So differentiate both sides with respect to t. That's going to give me 3x squared dx dt. Chain rule, right? So now I plug in the information I'm given. That's 3 times 3 squared, because the side length is 3, x is 3, and dx dt is 5. So that's 27 times 5, or 135. And what are the units? Units are going to be centimeters cubed, because it's volume, and per second. We're looking at a change of time. It's B. Final question. This is more tricky, right? So a ladder is 25 feet long and it's leaning against a wall of a house. So we have this ladder here. It's 25 feet long. It's leaning against the wall. And let's call these side lengths X and Y. And we're told that the base of the ladder, so that's this point here, is pulled away from the wall at a certain rate. So in other words, our length X is increasing at a certain rate, 2 feet per second. So dx dt is equal to positive 2 feet per second, because that length is increasing. We're also given the fact that the base is 12 feet from the wall, so x equals 12 feet. Finally, what we're interested in is how fast the top of the ladder is moving down the wall. So we're trying to find essentially how fast that side length y is changing. Okay? All right. Next, let's write the equation that relates x and y. That's simply going to be the Pythagorean theorem because this is a right triangle. X squared plus y squared equals 25 squared, which is 625. Then the third step is to differentiate both sides. So that's going to give us, right, I'll write it out. Differentiate both sides with respect to t. So that's going to be 2x times dx dt plus 2y dy dt is equal to 0. And now what are we looking for? We're looking for dy dt. Okay, so we know x. We also know dx dt here. But the problem is we don't know y. Now, the good news is that it's very easy to find because we know x and y we can find simply using the Pythagorean equation here. And so if we did that out, we would find that y squared equals 625 minus x squared. And so that tells us that y equals, get a calculator, y equals square root of 481. I don't think that's divisible by anything. Well, it's divisible by 13. 13 times 37. So we can't simplify that radical. And so now we know y, so we can plug that into our equation here. And we find that after plugging things in, that 2 times x, which is 12, times dx dt, which is 2, plus 2 times y, so 2 times root 41 dy dt equals 0. And so that tells us that 2 root 481 dy dt is equal to negative, what is that, 48? And so dy dt equals negative 24 over root 481. And that is approximately equal to don't have a calculator on me, but whatever that's equal to, that's in, what are the units? The units are going to be feet per second. Okay, so that'll be my answer. So that concludes this video. I hope it was helpful, and good luck on the test.